Chapter 7, Section 5, Solving Rational Equations. We just did the adding and subtracting. Man, that was a tough one, but we got through it. Doing all those fraction things with expressions instead of just numbers is tough, but it is doable. It just takes a lot of practice. So now we're going to start working on solving. And some of you are seeing a word in this thing, or a word phrase in this thing that you've been saying all year. Cross-multiplying. You can use cross-multiplying to solve a rational equation when each side of the equation is a single rational expression. That's the key. Each side has to be a single rational expression. So let's look at what we're talking about. Boom, right here. Basically, it has to be a proportion. A top and a bottom equal to a top and a bottom. That's the only time you cross-multiply. You cross the equal sign and multiply. So we've got 3 times 4x plus 5 equals 9 times x plus 1. So we've got 12x plus 5 equals 9x plus 9. Subtract 9x. 3x plus 5 equals 9 minus 5. 3x equals 4. Divide by 3. I don't know why I put a 4. And x equals 4/3. And x can't be, we had things in the bottom, it can't be a -1 or a -5/4. Okay? Unless I mathed wrong. Which I did. Because as I checked the answer in the book, they say it's -2, and I got 4/3. And let's go back and see where I mathed wrong. 3 times 4x is 12x. 3 times, there it was, 5, should be 15. And then we're going to subtract 15. And that's where it changes. Those are still good. Undo. Okay. But it should be -6 divided by 3, which makes it -2. Everybody slips up. That's why you check your answer and make sure you're doing good. And you go, oh, yeah, don't forget, draw your lines so you remember to multiply everybody and everything. It happens. That's why I don't take it out of my videos. I want you to know everybody's human. Everybody makes a mistake. We're not looking for perfection. We're looking for consistency. If we don't make the mistake all the time, we're doing a good job. All right. Writing and using a rational model. So a ratio is just a one fraction compared to another. So an alloy is formed by mixing 2 or more metals. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. You have 15 ounces of 800 grade silver, which is 80% silver and 20% copper by weight. How much pure silver would you mix with the 800 grade silver to make sterling silver? So we have to make a proportion out of this. So we need the percent of copper in the mixture to equal the weight of copper in the mixture divided by the total weight of the mixture. Okay? So how much do we need to add of pure silver? Well, the percentage of copper in the mixture is 7.5%. And that's out of 100%. So we're going to compare it to how much is in there and how much silver we need, right? We already know where it is, right? So we're just picking one of these that it needs to be. And what we know, we have 15 ounces of silver, so how much do we need to add to get a ratio that turns it into 7.5 out of 100? Well, when we deal with the copper, when we deal with the copper, we've got 20%, right? That's 0.2. And we've got the weight of the copper in the mixture. We have 15 ounces, right, of 800 grade silver. So 0.2% of that is copper. So 0.2 times 15 is how much weight we have in copper. Okay, don't really need the 0.75% on there. That gives us our percentage of copper, because 20% are weight in copper. So if we were out of 100, we need 7.5, because that's what 7.5% is. So if we are out of 15 ounces, we need to know how much we have. We have 20% of that weight is copper, so we're going to do that. Now, out of the total weight, okay, 15 plus how much? Okay, that's what we need. How much are we going to add to the total weight so that the percent drops down? Okay, that's going to be my variable, x. So now we just need to solve for x. So I would cross multiply. 7.5 times 15 plus x equals 100 times 0.2 times 15. Okay. So that's 7.5. Well, let's just go ahead and do that multiply, right? 7.5 times 15 is 112.5, and 7.5 times x is 7.5x. We multiply these together. That moves the decimal place twice, which makes it 20. And 20 times 15 would be 30 with a 0, so that would be 300. Subtract the 112.5. 7.5x equals 187.5. And divide by 7.5. That one I got to do. 187.5. No, 0.5. Still 5. There we go. Divided by 7.5. X equals 25. We need, that's a bad 5. We need 25 ounces of silver, pure silver, to add into the 800 grade silver to make it sterling silver. That's what we would do. If a question like this comes up, hint, hint, in your homework, work it in the same way. Use that as a model. All right, so let's solve these by cross-multiplying, and don't forget to check your solution. Plug it back in. Something weird might happen, okay? So give it a pause, give it a try, come back. Let's see how they go. All right, here we go. Cross-multiply. 5x times 2 is 10x. 3 times x is 3x. 3 times 7 is 21. Move the 3x. 7x equals negative 21. Divide by 7. X equals negative 3. Let's plug it back in and make sure. 3 divided by 5 times negative 3 is negative 15. So 3 over negative 15. And that reduces down to 3 goes into that once. It goes into that 5 times. So negative 1/5. All right. 2. And we're going to do negative 3 minus 7, which is 2 over negative 10, which is negative 1/5. That checks out. We're good. Okay. Let's go greenie. Cross multiply. 5x plus 15. Look, I learned my lesson. Negative 4x plus 12. Add 4x. 9x plus 15 equals 12 minus 15. 9x equals negative 3. Divide by 9. X equals negative 1/3. Ugh, gross. Negative 1/3. Seems good. Let's plug it back in. Oh man, 3/3. That'd be 9/3 minus 1/3 is 8/3 on the bottom. And when we go negative, negative, we get 10/3 on the bottom. 5, 3 over 10. That's going to be, so negative 3 over 2. All right. And we did negative 4, 8/3. So negative 4 times 3 over 8. 4 goes into that once, goes into that twice. Negative 3 over 2. Checks out. Cross multiply. 11x plus 8 equals 2x squared plus 5x. That's a quadratic, so get it all on one side, set it equal to 0. So minus 11x minus 8. So 0 equals 2x squared minus 6x minus 8. I'm going to divide the 2 off of all of that. So x squared minus 3x minus 4. We're going to factor it. 4 factors into 4 and 1, and it needs to be negative, so the 4 is negative. So x equals 4, or negative 1. Now we should plug them back in and make sure they both work. 1 over 4 times 2 is 8, plus 5 is 13, so 1/13. And 4 over 44 plus 8. 4 over 44 plus 8. So if you take 6 off of that, it makes 52. And that goes in 1/13. So yes, that one checks out. Negative 2 plus 5 is 3. And negative 2 over, oh, no, negative 1. Hello. Negative 1 over negative 11 plus 8 is a negative 3. Negative, negative makes positive. Checks out. They both check out. We're good to go. Solving by using the least common denominator. When a rational equation is not expressed as a proportion, you can solve it by multiplying each side of the equation by the least common denominator. This is what we were talking about before. We get an expression that has the denominator in it that are not all the same, and we need to get rid of them. Multiply what their next least common denominator could be. Well, the 4 is missing an x, and the x is missing a 4. And so we have to multiply by that on the tops as well. So if we multiply by 4x to everybody, drop the x, multiply by the 4, makes it 20. Drop the 4, multiply by the x. Drop the x, multiply by the 4, then solve. Boom. We should plug it back in and make sure, but it's fractions, who really wants to? 5 over negative 8, so that'd have to be 14 over 8. So negative 5 and 14 makes negative 9 over 8, which is what happens on the other side. Great, checks out. What are they all? So it needs to be times x and x minus 5. So that makes it x times x minus 5, that's the 1, minus 8x, because the x minus 5 goes and left you with the x, equals, and then 3 times x is 3x, and 3 times negative 5 is negative 15. So we got x squared minus 5x minus 8x equals 3x minus 15. It's a quadratic, so move everybody over. X squared, we got negative 5 and negative 8 is negative 11. So minus 14x plus 15 equals 0. Then we just have to factor it. Factors of 15 that add to 14. Let's see. Is she factorable? Oh, wait. Did we do that math wrong? Because that is not factorable. Let's double check our math. 5 and 8 is not 11. It's 13. 13 and 3 makes 16. Hey, there we go. Now it's factorable. Factors of 15 that add to 16 is 15 and 1, and they're both negative. So that means x equals 15 and 1. We should check them back in. So let's try it. 15 minus 5 is 10. 8 over 10 is 4/5. 1 minus 4/5 is 1/5. Oh, wait, but we got to go fifths. Right? Okay, so 8, 15 minus is 10. 4/5 is 5/5, so there's a 1/5. 3 over 15 is 1/5. Okay, so that checks out. 1, so that makes it add 1 plus 8. Let's see. No, 1 minus 5 is -4. So that becomes a 2, and it becomes plus 2 and makes it 3. 1 divided by 1 is 3. Those both work out as well. Very good. Here are some for you to try. Solve by using the least common denominator method, and come back and check them out. All right. The least common denominator, I got an x, I got a 5. So 5x is what I'm going to multiply by. Drop the x, multiply by the 5. 50 plus 25 is 75. Plus, drop the 5, multiply by the x. 4x. Drop the x, multiply by the 5 is 35. Minus 75. 4x equals -40. Divided by 4. X equals -10. Wow. 15 divided by -10 is -3/2. And over -10, they'd have to be 10s. One's negative, one's positive. Already has a oh no, they would reduce. Nope, 2 doesn't go into it. So leave it as 15 over -10 plus 8 over -10 is going to make it a -7/10, which is what the other side does, so that's good. Let's try this one. We need a 2x times x plus 1 to everybody. The x plus 1 drops, so 2x times 3x is 6x squared. Minus, drop the 2x, we got 5x plus 5 in parentheses, or you could go like this and make it a -5. That's probably what I would have done, is changed it into a plus. So then we've got, when it's times that, -5x minus 5, that's better, equals 3x plus 3. It's quadratic, so we got to get everybody to one side. So minus 3x minus 3 minus 3x minus 3. 6x squared minus 8x minus 8 equals 0. Take out the greatest common factor first, make it smaller, so we can divide everybody by 2. So we got 3x squared minus 4x minus 4 equals 0. Slide to the back. X squared minus 4x minus 12. Factors of 12 that subtract to 4 would be 6 and 2. It needs to be negative. Don't forget, if you slide it, you gotta divide it. X minus 2 and x plus 2/3 equals 0. X is 2 or 2/3. Nope, negative 2/3. Don't forget opposite to get out. Hello. And just because I'm out of room, make something like this. Let's do number 6. Let's factor that bad boy apart first. X plus 1 times x minus 1. All right, so that's what we're multiplying, top and bottom. So this top becomes x minus 1 times 4x plus 1 equals 12, and then plus 3 times x plus 1 times x minus 1. So it's going to be quadratic. We got to multiply it all together, move it all to one side, get it figured out. So x times 4x is 4x squared plus x minus 4x minus 1. 12 plus 3 times x squared minus 1. So we got 4x squared minus 3x minus 1 equals 12 plus 3x squared minus 3. And I'm going to move things this way, 3x squared. So that becomes, ooh, that was weird, just an x squared. Minus 3x minus 1 equals, that went. 12 minus 3 is 9, so I'm going to subtract 9. So x squared minus 3x minus 10 equals 0. And we're going to try to factor it. Factors of 10 and subtract a 3 is 5 times 2. It needs to be negative. So x equals 5 or negative 2. Whew. Man. Mr. Magger, you do that so fast. Well, it's actually pretty slow. And I've had a lot of practice. That's why I get to do it faster and faster and faster. The more you do it, the more you get used to what's going to happen and you know how to do the next move before you're even on it yet. So practice, practice, practice. When solving a rational equation, you may obtain solutions that are extraneous. Be sure to check extraneous solutions by checking your solutions in the original equation. You can also graph the original equation and then see where it crosses the x-axis, which ones work and don't work. Okay, you can always set this as one equation and this side as another equation, y equals, and see where they touch. But let's do it by the math. All right, so this is x plus 3 and x minus 3. So the thing that they all need is that. So if I multiply x plus 3 and x minus 3 times every piece, this first one, the x minus 3 goes away and I get 6 times x plus 3 equals the 8x squared stays. We're going to drop both that time. And then it's going to be negative 4x times x minus 3. It's got a squared in it, so we got to get it all to one side. So 6x plus 18 equals 8x squared minus 4x squared plus 12x. Move the 18, move the 6x. Okay, those go, gives me 0. 8x squared and 4x squared is 4x squared. 12x minus 6x is minus 6x. And then minus 18 at the back. 2 goes into all of them. So 0 equals 2x squared minus 3x minus 9. Slide to the back. The 2 just slid. Goofy. Okay. Factors of 18 that subtract a 3 would be 6 and 3. Needs to be negative, so that goes like that. If you slide it, you got to divide it. So 0 equals x minus 3 and x plus 3 over 2. So x is positive 3 or negative 3 over 2. Now, what they tell us is to plug in these answers and make sure that they work and don't give you something weird. So if we plug in the 3, 6 over x minus 3, and we put in a 3 for that, that becomes 3 minus 3, that becomes 6 over 0. So that's one of our limits that x can't be. Remember back here, x cannot be positive 3 or negative 3. So 3 is out. Now, negative 3 over 2 should probably work. I'm going to do that one in the calculator. 6 divided by negative 3 over 2 minus 3 is negative 1 1/3. Oh, so negative 4/3. And if I do 8 times negative 3 over 2 squared divided by 3, that's supposed to be negative. Negative 3 over 2 squared minus 9 minus 4 negative 3 over 2 parentheses divided by, nope, too many. There we go. Negative 3 divided by 2 plus 3. Hey, oh, something weird. So do either work? Do none work? What happens there? Was it 3 over 2? Negative 3 over 2. What happened? It's got to be a negative 6. Supposed to be positive in the middle. Let's see what happened. Where's my x bar? Oh, look at that. Here's my correction. Should be this, which is this and that and that and that, which changes it to this. It's still wrong. And that. And so now I got to just take off all those negative signs. Not 32. And 3 halves. 4 times 3 halves. Oh, but this top one should be that way as well. Look at that. Dunk. Oh, -4, -4. I like it when it works. There we go. Again, look at me. Fast mathing, and I put a -6 instead of a +6, and it got me off. But when I checked my answers and got nothing, I go, oh, wait, something's weird. Go back, look. Oh, I see. So make sure you look for those and find it. And always check your answers. Here's a try for you to try. Go slower than I did. That way you don't make a mistake like I did. Or learn from my mistake. That's why I do them first for you. But give these a shout. Try them. Pause it. Come back. All right. X plus 2 times x minus 2. So they all need a one of those. So it's going to be 9 times x plus 2 plus 6x times x minus 2 equals 9x squared. 9x, 18, 6x squared, -12x, 9x squared. Let's go ahead and move this over. All right, 9x, and let's see, we'll do this part first. 6x squared and -9x squared is -3x squared. 9x and -12x is -3x. And plus 18 equals 0. I'm going to divide everybody by -3. So that becomes x squared. It becomes plus x. It becomes -6 equals 0. And then it becomes factorable. Factors of 6 is subtract to 1 is 3 and 2. The 3 is positive. So we say x equals -3 or 2. X back here is not allowed to be a 2 or a -2, so I already know that's out. So we can plug in the -3. -3 minus 2 makes it 9 over -5. And -3 is going to make that a -1. And that's a -18, so that's plus 18. So 9... -9/5 plus 18 is supposed to equal 9 times 9 is 81 divided by 3 minus 4 is 1 is 81. Let's see, does it work? Let's just do the big one in the calculator, see how it goes. All right, so 9 divided by -3 minus 2 plus 6 times -3 divided by -3 plus 2. All right. And 9 times -3 squared divided by -3 squared. Oh, nope, down here. Minus 4. 16.2 and 16.2. It works. Use it. Okay. I don't know what's going on there. Slide to the right. There we go. All right. Getting close. Let's try this one. This would be x plus 1 times x minus 1. That one already has an x minus 1, so it becomes 7 times x plus 1 minus... I'm going to do plus -5 times x plus 1 times x minus 1. It gets both since it doesn't have any denominator at all. And then the 6 just stays because it already has both. It doesn't need them. So we got 7x plus 7. And we know this is x squared minus 1. And so that's negative 5x squared plus 5 equals 6. And we're going to subtract 6 from both sides. So negative 5x squared plus 7x. 12 minus 6 is positive 6 equals 0. I'm going to divide the negative off because you don't want to start this without that. So 5x squared minus 7x minus 6 equals 0. Now we can do the slide to the back. We're looking for x squared minus 7x minus 30 equals 0. Each one gets an x. Factors of 30 that subtract 7 would be 10 and 3. And that needs to be negative. If you slide it, you got to divide it. Remember, back up here, x can't be 1 or negative 1. So x minus 2 and x plus 3/5. I don't slide the 5 in front because I'm going to immediately just come right out of there and say opposite to get out. So 2 and 3/5. And my guess is that they're both going to work. Okay. Now, don't forget that one's negative. There we go. Opposite to get out. Those are my answers. So let's do this. Let's say, I wonder if I can do it this way. 7 divided by x minus, actually I'm going to use a different letter. I'm going to do divided by b minus 1, and I'll show you why I'm doing that in a second, minus 5. Okay, and then I'm going to do the other side, 6 divided by b squared minus 1, and it says add a slider for b. I'm just going to say b equals 2. They both come out to 2, so 2 works. And I'm going to change out 2 for negative 3 divided by 5. And I got negative 9 point. There we go. I only had to type it once that way. I just put the variable in there and then told it what the variable was, made it do the substitution. So all I had to change was the b once I got it typed. I didn't have to retype it twice. Okay, but both check out, and so both are good. All right, finding the inverse. We've done inverses before. All you got to do is switch the x and y, resolve for y. So consider the function f of x equals 2 divided by x plus 3. Determine whether the inverse is a function and find the inverse. Well, let's graph it. All right, y equals 2 divided by x plus 3. Is it going to pass the horizontal line test? Why, I think it should. Just doesn't touch when x is negative 3, and it won't touch when, and then it'll be forever in both directions, no problem, no matter what. Okay, but you should be good if you reciprocal that. So let's try it. Okay, switch. So make it x equals 2 divided by y plus 3. I'm going to treat it as over 1 and do like this and say x times y plus 3 equals 2, then divide by x, so y plus 3 equals 2 divided by x, and then subtract the 3, so y equals 2 divided by x minus 3. If we want to put that over one denominator, I'd have to multiply it by x over x, so y equals 2 minus 3x over x. Would it be a function? Well, at this point, x can't be 0, so that becomes an issue right there. So is it a function? Well, if we look in the book, they tell us graph the function f. Notice that no horizontal line intersects the graph more than once, so the inverse is a function. That's what we did. We graphed it. If you drew a horizontal line on there anywhere, it would never touch it more than twice. Okay, so then it's, okay, we find it. So we found it. There it is. And they said call it g of x. So instead of y, I'd say g of x. That's all it takes. Just switch the x and y. Get y back by itself. All right, back in 7.2, which we may or may not have covered. Example 5, you wrote the function c equals 50m plus 1,000 over m, which represents the average cost in dollars, C for cost, of making m models using a 3D printer. Find how many models must be printed for the average cost per model to fall to $90 by A, solving an equation, and B, using the inverse of the function. Okay, so first we're going to plug in. So the average cost is what C is. So this goes in for C. So part A is they want us to plug in the 90 and then solve for M. I'm going to say over 1 and do that. So 90M equals 50M plus 1,000. And subtract 50M. So 40M equals 1,000. Divide by 40. So boom, M equals 100 over 4. 4 goes into 100 25 times. So we should get 25. Now if we find the inverse, we can then just plug in the number and figure out what happens. So B, find the inverse. Okay, so we're going to switch it. Where one thing was, the other thing goes. Now, what did they do there? Now, the deal with this one is we don't want to switch their places. We just want to get one letter by itself, which is the M part. Okay, so if we start with C equals 50M plus 1,000 over M. We want to get the M by itself. We don't want to switch C and M because they're not exactly the same thing. We talked about this when we did inverses before. If it's just X and Y, you can switch them and then resolve. But when they actually mean something in the real world, you have to keep them where they are. So let's separate the fraction part into two pieces first. So C equals 50M over M plus 1,000 over M. Now, the M goes bye-bye here, and we got wrong button. C equals 50 plus 1,000 over M. Now we just want to get rid of all of those bad boys. You could have also multiplied the whole thing by M, and that would, or cross multiplied here and got CM equals 50M. And then you'd move over and get a common factor out of M and you'd get rid of it. But this is another way to do it. I'll work it the other way in just a second. All right, so move the 50. So C minus 50 equals 1,000 over M. All right. And now what we want to do is switch their places. Now with proportions, you can switch one diagonal direction at a time. So if I've got, wrong button. If I've got this over 1, I can switch one diagonal direction and it's still in equal proportion. So I can switch M over on this side and then put the C minus 50 on that side. Now, this is a lot more work than just plugging the 90 in and getting M by itself, but okay, they asked us to do it, so we do it. Okay. So then we can say, okay, all right, plug in 90. So 1,000 divided by 90 minus 50. 1,000 divided by 90 minus 50. Still 25. Look at that. Okay. Still get the same answer. M equals 25. Okay. Let's look at another way to, actually I don't want to undo that. I want to just do this part right here. So I'm going to work it one other way. We can treat it like this, cross multiply, so we get Cm equals 50m plus 1,000. Get all the m stuff on the same side. So we got Cm minus 50m equals 1,000. And then you take out the common factor of m, you got C minus 50. And you divide, by C minus 50 on both sides. m equals 1,000 over c minus 50. So if you know the cost, and you want to find out how many models you need to make in the first place, then you can use that equation and just reverse it, get the inverse. All right, so here's an example of both of those kinds of things. Press pause, give them a try, come back, see how to work them. All right, number 9. Consider the function f of x equals 1 over x minus 2. Let's see if it's inverse. So 1 divided by x. That's not what I wanted. I wanted a 1 divided by x minus 2. It will be a function. So yes. So we got to say x equals 1 over y minus 2. And we have to get the x by itself. So we're going to add 2. X plus 2 equals 1 over y. And then we can use that proportion rule and just switch diagonally one direction. So y equals 1 over x plus 2. There's our inverse. How do the answers in example 6 change when c equals 50m plus 800 over m? Well, let's say we plug in 90 and we say 50m plus 800 over m, and we separate. That goes, so minus 50. So 40, not 44. 40 equals 800 divided by m. Switch. So m equals 800 divided by 40, which means m, that's a weird m, equals, let's see, if that's divide, goes in 2 times, you only need 20. So to drop down $200 in cost, or whatever that, what was that one originally? 1,000. I don't remember what the 1,000 was for, but if you drop the 1,000 down to 800, you only have to make 20. All right, that's it. That's the monster.